So, this graph shows the velocity of a car. Find the integral from 0 to 7 of v of t dt and describe its meaning. Okay, so this is velocity here. Integral from 0 to 7 is going to be area underneath the curve here. That is a trapezoid. That's probably how I would do it. But you could do two triangles and a rectangle there in the middle if you want. And so we would have 1/2. The height of that trapezoid is 2. The bottom base would be 7. The top one would be 2. So that is going to give you 9 for that. Now, let's think about what this means as far as meaning. That's what I think is the hard part of this. So it tells us that this is velocity in feet per second. So this is feet per second. Goes on this axis, and then this axis would be seconds. So to me, it helps a lot to think about units before I even start to think about what this means, right? So if I'm finding the area under this curve, what are the units of my answer going to be? This is going to be feet, because I would be doing feet per second times seconds, right? Because when I'm doing area, it's sort of length times width. I realize this is a trapezoid, so it wasn't a rectangle, but if you think about doing all those little tiny rectangles, we could add them together, right? So you're doing length times width. Length is going to be measured in seconds, or I guess we could say height right here is going to be measured in feet per second. Seconds cancel. We just have feet. So this is 9 feet. Is it talking about a velocity if the answer is 9 feet? No. Okay. So we would say here, we're talking about from 0 to 7. So we're not talking about at 7. We're talking about a time interval here. So we would say from 0 to 7 seconds, the car travels. Actually, let's see. Well, it's okay to say travels here. Travels 9 feet. It does not mean it is at 9 feet, because maybe it started at 12 feet, and then it added 9 more to it, right? But it traveled a distance of 9 feet. It is okay to say that it traveled a distance of 9 feet here, because what direction was it going in? It was going in positive direction the whole time, right? So, however far it traveled is how far that it went. Now, we're going to see something different here in a second. Okay. Now, let's find the integral. I don't know why that says 18. It should say 10 right there. Let's fix that. Okay. The integral from 9 to 10. Did I mean for that to be 9 to 10? I feel like we should have 7 to 10. Let's make that 7 to 10. We could do 9 to 10. I think it just makes more sense for me. I must have changed the graph and not changed that. So from 7 to 10, we again have a trapezoid here, right? So the integral from 7 to 10 of v of t dt is going to be, we'll have 1/2 times the height, which is 4, and then base 1, which is 3, and base 2, which is 1. And that is going to be 2 times 4, which will give us 8. Oh, wait, hold on. It's not 8. What is it? Negative 8. Okay. And again, this is going to be feet, just like it was last time, right? What's the meaning of that, negative 8 feet? Correct. Opposite direction, 8 feet. Which, does it say left or right, or? It just says a straight highway, so we'll just say in a negative direction for this one. From 7 to 10 seconds, the car traveled 8 feet in the negative direction. It'd probably be okay to say backwards there. Okay, now let's talk about the interval from 0 to 10 of v of t dt. So that's this entire interval that we see here, right? That would be our interval from 0 to 7 of v of t dt plus our interval from 0 to 7 to 10 of v of t dt. And we already found both of those. We got a positive 9 for that first interval. We got a negative 8 for the second interval. We got 1 foot. Okay, what is that? What's that mean? It is where the car ended up in relation to where it started, right? So a good word to use for this is your displacement, right? We've talked about this before. I like to use the example about going to the bathroom. If you're going to the bathroom, you leave my room, you go down here, that bathroom is closed. You have to go back up here to the other bathroom, right? Your total distance traveled is a lot further than your displacement, right? Because you had to go one way, turn around, and then go back. So what you don't want to say here is that, well, you're going to start off with from 0 to 10 seconds. You don't want to say the car traveled 1 foot. That is false here, right? We could say that for example 1 and example 2 because the car only went one direction on that interval. But the car goes more than one direction here. So we have to say from 0 to 10 seconds, the car moves 1 foot from its original position. Or we could say the car is displaced 1 foot there, but we don't want to say it traveled 1 foot because it went further than that, right? Everybody good there? Okay, if the car is located at the point x equals 0, at t equals 0, so it starts at 0, 0, right? Then I'm supposed to find the values for the position at each one of these points, right? So my car is starting off at 0. At 1, well, 1's a little hard to do. Let's do, and I can do 1. I can do 1. All right. At 1, how far does the car travel? I think it's less than that because it's going to be 1/2 times 1 times 0.5. We'll get 1/4. All right, what about at 2? 1 for that, because that little triangle is going to have an area of 1. 3, that's going to be 1.25, because we're just, no, 2.25, right? Yeah, because we'll have, this was 1, this will be 1, and that little sliver right there is 0.25. So 2.25. And then for the 4, we're looking at 4 for that. Just area of that triangle would be 1/2 times 4 times 2, which would give us 4. We're all the way over here. Okay, here.
Oh, I see.
It's like the tire blocks and not just the little sliver blocks.
Yeah, you're looking at this triangle right here. So like each one, we're not going like we're not looking for the change from 1 to 2. We're looking from 0 to we're not looking from like 2 to 3. We're looking from 0 to 3. Right? Total distance there. Okay? So the next one at 5, we'd add 2 more blocks, so that'd be 6. Here we'd add 2 more blocks, so that would be 8. At 7, we would add 1 more block, that'll be 9. Okay, what starts happening at 8? We start subtracting. All right, so at 8, what would we get? Back to 8. What about at 9? I think it's going to be 5, right? Because that would be 2 full blocks, and then these 2 together would make a full block, so I think we'll get 5 there. And then I ran out of room on this table, but let's add 10 on the end. What would we get there? 1. Now, if we kind of think about what we've already done for this graph, at 7, we had 9 feet, right? That's what we found. That was the distance traveled. And then at 10, we're back to 1 foot, which is what we found for our displacement there. Now, this is all if we start at 0, okay? We sometimes do not start at 0. So, the fundamental theorem of calculus, we have already looked at one version of the fundamental theorem of calculus, which was that if we took the derivative of an integral, it gave us the function. So we may want to sketch in because there's 2 different iterations of the fundamental theorem of calculus. There is, if I take the derivative of the integral from a to x of f of t dt, right? If I take the derivative of an integral, then it is just going to give me the function f of x. All right, so that's the fundamental theorem of calculus that we have already looked at. Another application of the fundamental theorem of calculus is that if we integrate from a to b, it is the same as taking capital F of b and subtracting capital F of a. Okay, let's look back here and sort of think about it. If I want to know the distance here, capital F of 7 would be 9, capital F of 0 would be 0, 9 minus 0 would give us that value. So if I have, if I'm integrating from 1 to 4 v of t dt, when I integrate velocity, what do I get? Velocity is my first derivative, so if I go back, what function am I going to? I think I heard it over here. Position. And typically, they usually use a S or a X for position there. So when I integrate velocity, I will get x of t, the position. And then I'm going to write it like this, because we're going to use this notation a little bit. So when I integrate velocity, I get position from 1 to 4, which will be x of 4 minus x of 1. And so if you think about this, what you're doing here, this is the position at t equals 4 minus position at t equals 1. That's your displacement over that time period, right? Wherever you stopped at t equals 4 minus wherever you started at t equals 1. If we integrate acceleration, what do we get? Velocity. So if I integrate velocity from zero, integrate acceleration, I get velocity. That'll be v of 3 minus v of 0, which is taking your velocity at t equals 3 and subtracting velocity at t equals 0. It's your change in velocity over that time, right? This is your change in position over this time, is what we're looking at. And we got some more questions to look at. We'll look at them after your FRQ quiz tomorrow. This already only had those last 3 as an assignment.